Just as there are laws of indices, there are also laws of logarithms. We need to know some of the basic laws and be able to apply them. So we'll start by writing down what some of these laws are, and then we'll have a look at some examples of how we can use them. To begin with then, if some number n is equal to a to the power of x, that's our index notation, then log to the base a of n will equal x. Also, we can say that the number n is equal to a to the log of the base a of n. So the base raised to the power of a logarithm to the same base of any number just gives us the value of that number. So n is equal to a to the power of log to the base a of n. The next law is log of pq is equal to log of p plus log of q. Log of p over q is the same as log of p minus log of q. And the last one that we need to know is log of p to the power of n is equal to n log of p. Let's have a look at how we put these laws into practice then. In the first example, we're going to write log to the base 2 of 80 in the form of k plus log to the base 2 of 5. So we can start by saying that log 2 of 80 is going to equal log to the base 2 of 16 plus log to the base 2 of 5, because 5 times 16 is 80. But log to the base 2 of 16 is just going to be 4, so it's going to be 4 plus log to the base 2 of 5, so that's our answer. In the second example, we're going to write log of xy all cubed divided by z to the power of 4 as a sum of logarithms. So we've got a product of x and y cubed on the top, and we're dividing by z to the power of 4. So we can write this as log of xy cubed minus log of z to the power of 4. The left-hand term we can write as log of x plus log of y cubed. Then we've got the log of z to the 4. Then we can use the rule that log of p to the power of n is the same as n times log of p. So this will give us log of x plus 3 log y minus 4 log z. In the third example, we want to write 2.5 to the power of log to the base 2.5 of 4 as a number. Well, we know that if we have the base, which is raised to the power of a logarithm having the same base, it will just give us the number. So 2.5 to the power of log to the base 2.5 of 4 will just equal 4. In the final example, we're going to write log to the base 2 of 8 over the cube root of 7 in the form k plus a log to the base 2 of 7. So we'll start by writing this as log 2 of 8 minus log 2 of the cube root of 7. We know that the cube root of 7 can be written in index form as 7 to the power of 1/3. So we can now write log to the base 2 of 8, which is going to be 3 minus 1/3 log to the base 2 of 7. And that's it. Now have a go at the multiple choice question.